Welcome to EduAero Classroom. In this tutorial, we will learn about gravitation. It is a common observation that all objects thrown upwards come down because Mother Earth exerts an attraction force on the object and it comes down. Newton explained this phenomena in his famous universal law of gravitation. So now let us talk about universal law of gravitation. In universal law of gravitation, Newton said that any two objects in this universe attracts each other with a certain force, and this force is known as gravitational force. According to this law, two objects of masses m1 and m2 exert a force on each other. The magnitude of this force is directly proportional to the product of masses and inversely proportional to the square of distance between them. In this diagram, there are two objects A of mass m1 and B of mass m2. The two objects attract each other with equal and opposite force, and this is actually the gravitational force. The distance between two objects is d. So the gravitational force F is directly proportional to the product of masses, that is F directly proportional to m1 into m2, and this F, the gravitational force between the two objects, is inversely proportional to the square of distance between them. Combining 1 and 2, we get F is directly proportional to m1 m2 upon d square, and removing the sign of proportionality and taking a constant in its place, we get F equals to g m1 m2 upon d square. Here g is known as the universal gravitational constant. The universal word states that its value does not depend on the location. In the whole universe, its value is same. The unit of g can be easily obtained by rearranging the terms in equation number 3. That is, g is equal to fd square upon m1 m2. It equals to nm square Newton meter square upon kg square. So the unit of g comes out to be Newton meter square per kg square. The value of g has been experimentally calculated to be 6.673 into 10 to the power minus 11 Newton meter square per kg square. This equation number 3, that is F equals to g m1 m2 upon d square, is the mathematical form of universal law of gravitation. This universal law of gravitation has an important role to play in our life. This law is the law which helped in explaining phenomena like the moon around the earth and the earth around the sun. Actually, it is the gravitational force which provides the required centripetal force to move in a circle to these planetary objects. The same force is responsible for holding our solar system. The tides in the ocean are caused due to the gravitational pull of the moon and sun. Now let us discuss about free fall. When an object of mass m falls freely under gravity, it gets accelerated by an acceleration g. And we know from Newton's second law, we know that F is equal to mg, that is the force on the object of mass m near the surface of earth falling freely. And by universal law of gravitation, we know that F is equal to gme into m upon re square, where me is the mass of earth and re is the radius of earth. Clearly from 1 and 2, we have got mg is equal to gme into m upon re square. Cancelling m on both sides, we get g is equal to gme upon re square. This is the acceleration with which any object falls freely under gravity. An important thing to note is value of g is always constant, as it depends on g, me and re, which are always constant. Now we try to calculate the value of g near the earth's surface. We know that g is equal to gme upon re square, and g is equal to 6.73 into 10 to the power minus 11 Newton meter square per kg square. Me equals to, that is mass of earth. Mass of earth equals to 6 into 10 to the power 24 kg. Radius of earth is 6.4 into 10 to the power 6 meter. Putting the above values in the expression of g, we get this expression, and solving the above expression, we get g equals to 9.8 meter per second square. An important thing to note is g is constant as long as the distance between earth's surface and falling object is much less than re, that is d much less than re. This is because when d and re are comparable, the expression for g, the denominator, changes because the denominator will become re plus d whole square.